Yes, we are live.
All right, I think we're doing a session on PCB design problems. So as I was saying, I had wired mine up, and then I did my run DRC checks, and this is going to be a different set of things. But so what I had like errors everywhere because every single connection I made was too close to other connections. And then I figured out that somehow, I don't know if I did this, but I had a solder mask expansion of 2 millimeters, which is like massive. And I don't know if I put that in
What,
there or if like
what is that parameter mean?
I think that when you are doing a surface mount components, one of the there's a solder mask that goes on that applies like the paste.
Okay,
And
okay.
so this is like extra space around the pad where you don't want to have anything else accidentally there because the precision of applying the component might be too small or something. I have a very sketchy understanding of what it was, but this was set for 2 millimeters, and I think that was meant to be 2 mils. And so, because like everything seems to be reported in mils, but KiCad is taking everything in millimeters, and that caused a lot of problems for other things earlier on. So I think maybe that's what happened. So I changed this down to like 0.125, and now I have no more problems with that particular problem. Oh, I may have crashed my PCB editor.
Yeah, it keeps crashing quite often.
I don't think I saved that. Is it gonna open back up? Where did it go? Well, anyway, so to finish the story, I had many problems being flagged, and so then I started rerouting to try to understand, like, how do I not have these things be so close together? And then I figured out that, like, even if I rerouted, it was still flagging them, and that's how I found the solder mask expansion issue. So I changed that value. Now I have many less problems, but it got me thinking, though, of like, well, just how packed in can I put these wires to places where I'm going to be hand soldering? Because hand soldering is going to be just that much more imprecise. So I was like, well, let's try to be a little bit more logical about how I'm going to route these things out. But it's a very complicated problem that reminds me a lot of trying to play Factorio. If you've ever played that game, where just like laying out my factory. It's kind of the same issue. Oh, and then the other problem that I had, besides just the expansion fields, was that the way that all my routing kind of broke up the fill areas in a way that violated some rule. Like my fill areas weren't contiguous enough because they were all being broken up by like this rat's nest of like going under and over in vias. So
Why?
Yeah, so it
Why?
was forming some islands, right?
it was forming it wasn't actually islands. It was calling it like if you split it into too many forks or spokes or something. Like it was
Okay.
too dispersed. It would allow you to do one of those, but not two of those or something. Yeah. If I could get this thing to open back up again, I would.
Why is the fill area important?
I think it definitely has to be contiguous, but I don't know what other geometry constraints are important and why.
Well, there are some electrical reasons. I don't know exactly. One of them is like the absorption of the EMC radiations. But yeah, but
Yeah,
for
I was thinking
slow,
there was some electrical
yeah.
engineering aspects to it.
So for high-speed circuits, it's useful there, and there are some other reasons I don't know. But we can search, right? Why is the ground plane needed?
Here we go. It's pulled back up here again. Looks like I didn't lose all my work. That's good.
Okay, it helps maintain signal integrity.
Okay.
Thermal relief connection. Yeah, I think maybe this was similar. This like spoke count. I think this was similar to the same error that I was getting, but I don't quite understand. This is for my 6-volt. Yeah. I'm running the
Yeah,
6 volt.
and
Oh yeah, here we go. So that's what my fill looks like. And it does not like that.
Mm. So you connected the fill area to what?
So this fill area, the fill area on the front side is connected to 6 volts, so that's like the battery input.
Okay.
And I don't know if that makes more or less sense than to do it to the 3.3 volt logic level. And then the backside fill is ground. And so I think it's, yeah, like this part over here looks isolated. That's isolated.
So where is the 6 volts?
The 6
In the
volt
board.
comes in, it comes in the battery here.
That's the only place you need. You have 6 volts, right?
No, 6 volt comes in here and then it's going to both of these chips. And then, yeah, that's it. Because I don't have a, I was considering maybe trying to power the board off the battery too, just to see if I can do it, but I don't know if I'm gonna be able to. That'll be a next version.
Mm.
Oh, and the 6 volt
But
is
you
over here.
you don't need the 6 volts fill on the top, right? Near the ESP32, or do you?
I don't think I have to, but I don't know.
So basically, in my board, what I did was like fill some areas with the battery near where the 12 volts are coming, and the rest with 5. So I had two fills, voltage with two fills. I don't know what's the effect on the actual
Instead of
PCB.
doing, so you didn't do the whole thing as one fill. You did like multiple fill
No,
zones.
yeah. So basically, what you could do is at the bottom half you could do a 6 volt fill, and then in the top ESP32 part you could do a 3 volt fill.
Yeah, that's a good idea. Let's see if I can do that.
And then like somebody was I posted this on Vodcast and this Farcaster, and somebody was talking about 90 degrees of traces, so it causes some signal problems. And
90
yeah,
degree.
for the 90-degree traces. So generally, what you do is when you trace it, you do it with a 45-degree angle.
Oh, I
Yeah,
was
and you
wondering
try
why I
to
was
avoid
trying to
these.
do that. You try to
Yeah,
avoid that sharp turn. Interesting.
so you try to avoid these 90-degree angles generally.
That is interesting. Okay. So if I did a fill like that, wait, how come it didn't prompt me what I was doing? Is this the right thing? There we go.
Is there an explanation why for 45 degrees is better than 90 degrees? And why not 60 or whatever?
Then I can share the screen. Wait.
Oh, that's
Causes the outer trace to be more narrowly etched than the standard trace width. And parasitic effect. Basically, yeah, and then when the signal is traveling through it, there will be more reflections. so it will reflect part of the electrical signal back. So that is one issue. So if you are having really high speed circuits, you would avoid all these.
Ah, okay.
But for the simple circuits, for our circuits, simple circuits, right
Yeah,
now at
it's
the
probably
moment, it
fine for
won't.
this, but that explains
Yeah,
why, like when it automatically tries to draw them, it kind of
yeah.
avoids a lot of those.
Okay. This has nothing to do with reflection or radiation, but any sort of sharp shape will concentrate the high electric field and make a dielectric breakdown or arc over more likely.
Because there's a sharp corner.
On high voltage PCBs, like 1 kilovolt. Okay.
Hello,
Hello?
Hmm?
are we online?
Yeah.
Yes.
Okay. Something happened to my internet. Yeah. There is no specific reason to prefer 45, but it's generally done at 45. I'll post this in the thread.
Thank you.
Little more than an artifact. Okay.
That's a good question. What are really old circuit boards doing?
Of course, corners cause reflections. Okay, this guy has done some electrical modeling.
Yeah, but what are you going to do
Yeah,
if the
and
software doesn't let you? The software tells you, warning, warning.
PCB ground plane. Crucial element in the construction. It is essentially the difficult metal layer.
Okay. Different nodes.
Minimize EMI and element need for extra ground traces.
Oh, add a handful of vias.
For top and bottom ground planes. Is that recommending putting a ground plane on both the front and the back?
Yeah, I've seen such boards where you have ground on both.
So is it preferable for me to put my 6-volt on there or another ground plane? And also, how would I possibly get this to connect up? I need 6 volts up here. And it can't get there.
You can You didn't try the auto router.
I didn't try the auto router.
Okay.
Wanted
But
to know
you
how
have
to
the
do it
plugin
myself.
right now. Do you have the plugin installed?
I need to install it, right?
Yeah, it's in the main KiCad screen. There should be a plugin.
Yeah. Plugin content manager. Free routing? No.
Yes,
Auto. What was it called?
free router or something.
An advanced auto router.
But once you have the fill zone, you can manually route it, right? Then it will clear out the fill zones as you are routing it.
Yes. Yeah, and then you actually have to manually tell it to. I think this is installed. You have to manually hit like. You hit like B and it regenerates the fill zone. And then. Yeah, so the ground one is has like good integrity there, but a lot of things aren't connected up yet. So,
But if it's a through hole, you could place some of the components on the other side, right? Since you're soldering it yourself.
yes, I could both put the components on there, but I can also like put a lot of the routes on the back. But I wanted the ground to be extra good because it is like all four, like these 4 pins are all ground. And it tries to use that for like thermal properties.
Okay.
So I wanted to have pretty good connectivity there, but I don't know.
Well, what is the dimension of the board?
Is 45 millimeters by like 100 millimeters.
Okay. Then does it fit on your small rover?
Yeah.
Or does it overhang?
The idea was that it would fit in the construct spaced one. It fits in one of those
Okay.
squares.
Okay.
Although I should probably double check that again. And then I was like, oh, this is with Osh Park or whatever it is. You pay like by the square inch. I was like, what kind of geometry do I need to actually make this $5 cheaper?
Okay.
Oh, and this is
Is it routing?
I can't. Did that thing install or what? What happened to it? I've got too many windows now. And let me hold on. Let me reshare this. See that? Back.
You have to apply, right? Apply pending changes and then it will install. Yeah.
Because I know I just want to say
Love
that it's
open source
difficult
software.
to read the letters in what that is doing.
It's not clear for me.
Oh, is it
No,
zero?
just we were talking about the quality of the recording, and I can read it.
Yeah, it
Okay.
will be actually quite close, and then like squint my eyes, then I can read it. But if I'm sitting like normally, I
No, I'm
can't.
just saying. So let's see what it's like in the recording.
Okay, so that equals rerouting. Ah,
What?
cool.
Unable to export.
It
Multiple
must
footprints have they?
it must not like my custom footprint that I created.
So what
If it
is
didn't do
called
it yet.
ref in the?
Ooh. Failed to generate the D. Okay, I get it. Board outline is malformed too. It really doesn't like my board well enough to use a plugin. This is not a good sign.
Really not.
Oh, yeah, so I was gonna do. Yeah, there we go. This is what it's gonna look like, I guess. Although, yeah, the other thing on my footprint is for some reason it added this header thing for my footprint, and this one I just left the holes.
Okay.
I don't know.
What are those connectors called? Those white ones. Yeah.
These are JST.
Okay. Yes.
Something. One of the JSTs that I happen to have, I think.
So these are also available in the horizontal versions, right? So, for example, in the tumbler, there are similar connectors, but they come out. You plug in horizontally, not vertically.
I don't understand.
It's
So
Horizontal
L-shaped.
versus vertical.
no, these pins are coming vertically on the board, right? They are coming
Like
up.
perpendicular
Yep.
to the surface?
Yeah, perpendicular to
Yes.
the surface. Yes.
Okay.
Yeah. But on the tumbler there are similar connectors, but they come parallel to the surface.
Oh, I see.
So I was just wondering if they are called something else or it's just a variant of the what JST, right?
Yeah, it was a little bit tricky to footprint editor. I don't know if I
Okay,
can see what
there are horizontal ones. Yeah, it's called.
yeah. They list them as vertical and yeah, vertical and horizontal, but I wasn't quite sure. Oh, I guess I can see that. Oh yeah, like that. Well, anyway, that's what I got. Do you want to try to explain your
Yeah.
reset problem? Or?
A lot of learning on this one.
Yeah.
I was reading one of the articles shared by YaRG on the 90 degrees line. Yeah, it's impressive that the measurements are in femtofarad. I wasn't sure what the F was meaning. So femto is smaller than pico, okay, which is already very small. And apparently, just that little can cause big problems, on the board. So it's really like, gotta be careful, right?
Yeah, but for these boards it won't cause much. It will just work fine.
Yeah, the article you sent is really nice about that because it's absolutely there is a problem, but after the right answer is it depends. As you said, it depends on the frequency and stuff like that, right?
Yeah.
So for
Yeah,
us, it's
so
still okay. Yeah.
so this is the problem. What I think what is happening. So when I was plugging in my ESP32 directly on the tumbler board, so it wouldn't boot up. It would get stuck. So and then yeah, it was also getting heated. So I couldn't investigate this further. And then what I did was make this plug-in board and then have this isolation between these 5-volt pins and the 3-volt 3 pins of the ESP32 Nano. But when I made that plug-in board, it was still not booting up, but the heating problem had gone away. So I basically that narrowed down the problem to this reset pin. And then what I did was I have this pocket oscilloscope, and then I just plugged the oscilloscope in and then probed this reset pin. So I saw a charging and discharging cycle. So
Oh wow.
this this pin should normally be high. It should be 3.3 volts, but it was having a square wave, and then it was with a changing duty cycle. That was basically so this is connected here, and then it comes from here. This 3.3.
The board itself has like a reset switch on it, right? Or no?
Yes, but that is just connecting it to the ground. So it's pulled high to 3.3 volts
Right.
with the resistor, and then when you press the switch, it shorts to the ground, and then the board resets. So it's coming from this. The 3.3 volt on the ESP32 is generated here. So there is a V in and then 3.3. So there is an inductor here, and then this connects to this one. And then I was also supplying 5 volts here, so this was also generated. This and this were being connected, and then somehow this inductor and capacitor are forming some charging discharging circuit. I don't know the exact, but it seemed like if you observe the waveform, it would like increase and decrease. So the capacitor and inductor were basically charging and discharging somehow. So yeah, but that basically narrowed down the problem. So I just
All
cut.
right. So you had connected the reset pin to 3.3 volts, or just the reset pin on.
No, I had connected the reset pin to the via the voltage translator to the reset pin here. But this reset pin is connected to 3.3 volts.
I
It's
see. So
pulled high.
you had wired two reset pins together.
Yeah.
One of them on the step down converter and one of them on the nano. And the reset pin on the step down converter is more complicated.
Yeah. So basically, this was the pin that was causing problems
Yeah.
because this is already connected on the ESP32 to 3.3.
Yeah.
And then I was like taking the 3.3 volts and supplying it here. So somehow they were getting connected, and then the charging discharging. Like I still don't understand it completely, but yeah, what I did was I have this pin. Where is my KiCad? Yes. So this was the. So these are the two reset pins, and these are connected to. So on the right side is the where it connects to the ESP, like the tumbler board, and on left side is where you plug in the ESP32. And then these pins, this horizontal line
Mhm.
is the reset pin. So I basically made a cut here on the bottom layer, and then on the top layer I made a cut here. It was which one? 1, 2, 3. Yeah, this one. So 2 cuts, and then basically the resets were isolated, and now it works fine.
Do you think
Yeah,
you
but I
meant
still
to connect those, or they just were both called reset, and so auto routing connected them?
no. It's supposed to be connected.
Why?
So, but they are not. But the isolation, the reset from here to here is not working. It will not work.
But one is the reset for the nano, and one is the reset for a different component, right?
No,
No. What is
because the
reset
reset
for?
is the same. The reset is the same on the entire. So even if you press the reset on the tumbler board, it
Mhm.
basically shorts the pin on the ESP32.
Yeah, but what was the other reset?
No,
Reset
there is
was
only
on.
one reset.
Oh, I thought you said there was a reset on the voltage converter, like a reset pin on that other chip. Isn't that what you said you connected it to? This one, yeah.
So this is the step down voltage, and then this is where the 3.3 volt is generated on the ESP32 board.
Oh,
And this, I was taking it from here and then connecting it. Wait, let me share that. So this is the 3 volt which is generated on that board, and this I was taking here, and this was getting connected to here. Here.
I lost your mouse. Where?
Here. You see?
Oh,
It's on
wait,
the
moving.
Bluetooth. So
Okay.
there is a voltage step down on the tumbler board too. And there is a step down from on the ESP32 board too. So yeah, I don't understand completely why that is happening,
Mhm.
but like the symptoms kind of narrowed down where the problem is. So basically, if the board is not booting, and it was remaining in reset, so like I narrowed it down to the reset line. That's how I
Well,
figured out the problem.
I guess I
But I
would
don't
have.
still understand what is exactly happening electrically in
Yeah,
this circuit.
I would just guess that like on a breakout board for a nano, lots of the pins are just like not going to be connected to stuff, including the reset pin, because you've already got a switch. You've already got like a switch for the reset, and so unless you were going to add another switch for another reset somewhere else, like you wouldn't need to connect that to anything.
Yeah, but then there was this switch on the tumbler PCB for reset. So I thought,
You
okay,
were
I'll wire
trying to
it up.
wire that.
Yeah. So basically, I tried to wire it up, and then thought I could use the same switch for resetting the ESP32 Nano.
Okay, that's
But
the piece that I was
then,
missing. Okay.
yeah, yeah. So, but now there is some other software issue. We have to figure that out. But I think we can work on it. I don't know. I have one extra ESP32, and then if somebody wants, I can send it. Mayor, you have a tumbler, right?
Yeah. Yeah.
How does the ESP32 Nano looks? Because I have 3 or 4 different kind of ESP32.
This one, yeah.
I think you. Yeah, perhaps it's. It looks like one of the dev kits, right?
Yeah, it is a dev kit.
It's a dev kit, okay.
So this is the board I made, and
Where would I plug it in?
so you have
Yes,
to remove
continue.
the Nano Arduino Nano from there. Yeah, and
Okay.
then plug this in. Basically, this is like a interface board between this and the actual tumbler board,
Hmm.
because this
Can
runs
you,
on
can you show the
3.3
other
volts.
side of it? Can you show the bottom side? So what you're saying is that those parallel set of pins fit in here,
Yes,
in here.
yeah,
Okay.
and there will be a small overhang, but yeah, it's fine. It won't
Okay,
fall
let's
off.
say I wanted to make a board like that myself. What do I do?
You will need. Do you want to design the entire stuff, or
No, you already designed one.
so you can just order it? I can send you
So,
the design files.
so how does that work? I understand. I'm talking for audience as well. How does it work? You designed the board. It's wonderful, and I want it too. So how do I get it?
Go to YaRG's electronic component Shopify store.
Yeah, I can sell
For
it on Tindi.
$200, he will send it to anyone who wants one.
Do you know what is Tindi? Tindi? I don't know the pronunciation. It's like a Etsy for electronics.
Yeah.
So I can sell it there.
What is it called? What's paste the link?
Tindi. Tindie.
Oh, okay.
So lots of
Hindi.
electronics hardware. So you can find a lots of customized stuff here. It's really nice site. I bought a couple of PCBs from here. So we can either sell it here, or if you have like know how to configure JLC PCB, uh, or PCB way, I think has a like a open source project web page. So where you just upload your project and other people can order that project. So that is one way to do it. Or we can host the production files generated from KiCad, and then people can just download this production files and upload it to JLC PCB or some other PCB manufacturer. Or I think like Eisler is the company in Germany. If you are in Europe,
Yeah, but this is a particular design that you made. So I need
yeah.
to tell people, give me Anuraj's design. How do I tell them that?
No, you will need the production files. So when you have designed the PCB, that those production files are needed for JLC PCB or some PCB manufacturer.
So they're going to be like in a GitHub repository, and I contact one of these people and tell them, make me one of these.
Yeah, so you just download the files from GitHub, upload it to your favorite PCB manufacturer, and then you should have it in
Okay,
here.
and how much will it cost? I see here
Uh,
10
10 to
euro.
15 for my board. It was 10 euros or 15 euros just for the PCB. Uh, and then if you want to assemble it, it's costlier in Germany, but it's way cheaper in China. So I got the entire board SMT mounted and assembled in 25 euros.
Mm,
And then shipping was around 20, and then taxes something. But if you are not assembling it and then using through all components, or soldering the SMT components yourself, then it's really cheap. 10 euros, $10 or something. $10, $15. It's really cheap.
I see. Okay.
Or we could sell some things here on Tindi.
Tindy. Okay, robot. We have robot kits. Okay. Ah, they sell puppy pie for $1,000. Well, they also sell no puppy pie pro. Regular puppy pie is $600. Nice. Yeah. Flea market. Ducky pad accessory.
ESP32 control board.
Excuse me a second. Okay, they have cool stuff.
It's all sorts of wild stuff on here. Custom made flipper zeros.
Yeah, well, I think they are like plugins for Flipper Zeros.
Yeah. Oh, yeah. I remember. I think I saw this site once before because I was looking at a PDP-11 clone that someone made as a kit you can buy for to assemble yourself.
A whole PDP-11 or just a little PDP-11?
It's a I forget what scale. It's certainly smaller. It's just like the front panel wired up to an ESP32, I think, with a
So it's an
simulator.
entire PDP-11 inside the front panel.
Yeah. Oh, there it is. Yeah.
This one.
Yeah. You know, I never learned how to use the buttons.
Tell me you don't want one.
Well, it's a Raspberry.
I don't think I had the 70. Oh, and you notice the laptop has a little, VT52 emulation.
Just to be faithful to the experience.
Ah, it's a Pi. They put it all on emulated on Raspberry Pi.
Yeah, it's here, right? Yeah, this one.
Yeah, I didn't realize. Yeah. And he sold 5,000 of them.
4,000 kits of. Oh my god. So yeah, it's good business, no?
Wow. Cool.
Okay, extra points for whoever builds the first PDP 11 based rover. Now that it's so portable.
Right. Wow.
I had a quick question. Rhett, at the end of your turn today, you had a problem of with the KiCad. So you ended up managing to, I don't know, compile or generating the final thing. But how confident are you that it's going to work if you send it to manufacturer, basically, based on the feedback from KiCad?
Yeah, my goal is to figure out how to whittle down all those errors to 0 before I would probably try to send it off to see what happens.
Well, I only checked the electrical DRC errors, and the rest I just ignored.
Well, there's another. It's giving me some error about the cut out footprint being wrong, and I don't actually know what I did when I added that. So
Okay.
maybe it's just like the box isn't actually closed or something. But that seems like something.
Yeah, it
that
was giving me lots of errors on footprints and silk screen that they are overlapping or something. I just ignored all of them.
Yeah, I think those only show up. At least in mine, those were only showing up as warnings, and I was like, well, a
Okay.
warning. I mean, all right.
Yeah, but at the same time, as a software developer, warnings is like, okay, we can ignore. But once hardware is involved, I will. I'm personally very careful with my interpretation of stuff, basically.
That's fair. I will probably
Uh,
at least look at them and see if there's something I can do or try to understand what they mean.
and I'm sorry, I have nothing else to say. It's just wondering, what could be the thinking and the mental mechanisms on how to make progress with confidence. Because software, it's let's just run it and see whether it breaks. Okay, it won't melt the hardware, but here it like the stuff can melt. Right?
I think that's why I really liked. I think I talked about this before, but there's this MIT course that was like how to make almost anything.
Yeah.
And the videos for 2020 were online, and so they do it part of their lab kit for how to build stuff. They have like a CNC machine that is rigged up to like create their own PCBs by like etching out the copper on the board. And that's their, like, for the electronics portion of it, they're like, there's no breadboards in this class. Any electronics you want to do, you build on this CNC machine. And then you can do that kind of rapid feedback. It's kind of like you do with 3D printing, where like you just build it and then you try to see if the thing can cut it out for you. And if it can, then you got a board. I kind of would like to have that. The feedback mechanism of, okay, well, it's $20 or whatever to have this PCB made. It's not a lot, but then I have to like wait a week, see if it works, make one little small change. Like, that's amazing that you can do that now, but also that's still slow.
Right.
Okay.
Especially after hearing Anuraj, and like, I've heard so many people be like, oh yeah, you try to cut a trace when something doesn't work right to fix it in the field because these PCB boards never work on the first time. I'm like, what are the chances of that happening? How hard is it to understand where these things go? Like, apparently it's super common. I have much less confidence now. Thanks a lot.
But the exciting part now is
That's right.
yeah.
Yeah, but I would like to see that Oshpark, how it goes, because I checked them for a couple of times, but I just went to the Chinese. Is it cheap? With the assembly, how much does it cost if you want to assemble the components too?
I didn't see their assembly price, and maybe they don't. They seem to not be pushing that very hard if they do it at all. Services. Prototype. Maybe they don't do assembly?
But some of these manufacturers do support open source projects. Even though they're like, if you're, I didn't check with Isler, but Isler, I know they support open source projects. If you're doing some open source project, they will, like, I think, sponsor something or give you some free PCBs.
Oh, that's interesting.
Yeah. But then you basically are hosting your files somewhere on GitHub or on their site.
Anyone can have anything I built.
Yeah.
Good luck. Yeah, they don't say anything about assembly, I think. So maybe they don't. Which is interesting.
Okay, we are on the top of the hour. Do we have something else? Or else we meet next week?
Alrighty.
Thank you.
Catch y'all later.
Next week.